welcome to this morning's session on Maths FET Term 1 and Term 2 with the Sharp 535 SA calculator. On the plan or the agenda for today is we're going to look at exponents and surds, number patterns, equations, trigonometry, functions, and then finance, growth, and decay. So quite a lot to cover. It did take us about an hour the last time, so it should be around about the same as well. And then the calculator that we are using this morning is the 535. It has 422 different functions. It is designed specifically for the CAPS curriculum, and you'll see as we go through the various sections or topics in maths, how well the calculator works for each of those topics as well. Then, of course, we have lots of resources where you can download this. And what I'll do is at the end in the chat function, I will just share this PDF with you. Otherwise, you're welcome to email me and ask me for it as well. So the link to the simulator, which is the calculator we're going to use today. Then, of course, Maths at Sharp has got your free worksheets from grade 8 to 12 for math, math literacy, and technical maths. It also has study guides for grade 10 and grade 12 as well. So calculator basics, just some quick things. If you haven't used this calculator before, orange button is second function. So that just activates any of your orange functions like your highest common factor and first common multiple. You've then got your alpha button, which activates things like your statistics, which we're not going to cover this term because it is covered in term 3 and term 4. So I would say end of July, beginning of August, we'll look at term 3 and term 4's work as well. Then, of course, mode will just allow you to change between the different settings or the different modes that we have, and I'll discuss that next. And then, of course, BS is for backspace, and that allows you to delete something. Then you have change, and change just allows you to change the way that your answers are displayed on the calculator. So from a surd or a mixed fraction through to an improper fraction through to a decimal. And then, of course, your equals button, which will help you find the answer, at least for maths anyway. All right, so our 4 different modes that we have are normal, stat, table, and drill. Now, I'm not going to cover drill today, but do take a look at your calculator and play with the drill function. It's really nice for mental maths. Basically, it just asks maths questions, and you have to then type in the answer. The calculator marks it for you, gives you a tick if you're right, and a cross if you're wrong, and then repeats the question again for you. So it's very patient. You can also ask the calculator what the answer is, and it will show you. Sorry. You can learn from your mistakes as well. Okay, so I do want to show you the shortcut class marks. So I'm going to bring up my calculator. Sorry. There we go. Okay, so let's say, for example, you set a test which is out of 70, and you want to convert your class marks into something which is a total out of 100. So at the top, you put where you want to convert your total to. So you want a new total, which is 100. At the bottom is the total that you are coming from, where you started. So our total for our test was originally 70. Then you press your right arrow key, you say times, and you type in your first student's marks. So the first student got 52, we'll just say 55 out of 70. And then you would press equals, and you'll see you get 78 and 4/7. And we can change that. That's where change comes in. So we can round it off to 79%. Now for your next student's marks, so the next student got 63 out of 70. You could just type in 63 and press equals, and what it does is it creates a constant ratio for you. So now you know that that student got 90%. And of course, you can do this for your entire class list. So you just keep typing in the marks the students got out of 70 and pressing equals to get your mark. So it's a really nice shortcut for you. So there's all the steps. All right, so exponents and surds. So I did share this with the grade 8s and 9s, but it's really nice to see for teaching the rules of exponents and reminding students about those rules. So if, for example, you're teaching the rule where you have the same base and you multiply, then you would add the exponent. So what I'll do is I'll do what happens if I multiply. Right, I'll get this answer here. And if I prime factorize that answer by pressing second function and p fact, I'll get 2 to the 7. Now, if I did this, so I added my two exponents together, I would get exactly the same answer. So we can see that these are equivalent. In other words, when I multiply with the same basis, I add my exponents together. Now, what's really great here is that you can also use the calculator to teach the surd rules as well. So I've done the prime factorizing with you in that example, but let me just go back and show you again, just in case. So to prime factorize anything, so for example, we have 568, you would press 568 and press equals, and then say second function and exp. You'll see in orange it says p fact, and you'll see that you get your prime factors. If your number is a prime number, what will happen is when you prime factorize, oh, I didn't pick a good example. If your number is a prime number, when you factorize it, it's simply going to remove that decimal. So you know that it did actually do something. So it would just be 31, which is your prime factor. Then, of course, we can talk through surds as well. And again, you can teach the same surd rules using the calculator. So, for example, when you take the square root of 2 and you multiply it by the square root of 3, you can multiply the insides and get left with just the square root of 6. So we can see here, it would be the same as saying, which is as above. So again, you can work through that as an investigation with the students, and it works for all of the rules as well. But if, for example, you try to do square root 2 times the cube root of 5, for example, it's not going to work because they are two different types of roots. So that's just an important thing to note. The other thing is when we talk about cancelling a root, so for example, we could say the square of a square root is just the value on the inside. So then if this was a negative, it wouldn't actually give you, it would give you an error because it's trying to do the root first instead of cancelling it first. So just a heads up on that one. Okay, so any questions with exponents or surds? We're all good? All right, cool. So let's talk through number patterns. So there's 3 different number patterns, types of patterns. So linear in grade 10 and geometric, which we cover in grade 11 and grade 10 actually, I think. And then of course quadratic, which we cover in grade 11. So I'll just go through all of the basics. So some nice things to note here for number patterns is because we can't give them the Tn is equal to An plus D formula, we can give it to them as a straight line formula. So your difference is your common difference between the two. So here 14 minus 11 is 3, 17 minus 14 is 3. So our common difference is 3. So our pattern is linear because it has a repeating common difference. Now to find our C value, this back value here, what we would do is just go one step backwards. So we would say 11 minus 3 is 8. So our formula is 3n plus 8. Now we can, of course, check that we are correct by putting this into our table. Okay, so on your calculator, we're going to go to table mode by pressing mode and then 2 for table. Then the formula that we created was 3n. So we don't have an n here. We would always use an x in your function. So we would just press RCL twice to make an x plus 8 and then equals, leave function 2 equals, leave your start at, well, actually you can make a start at 1 and your step is 1 because it's a pattern. So your pattern always starts with a position of 1. Even though your calculator can go back up, so it doesn't matter where you start. It's good to remind them that the pattern starts at 1, otherwise confusion will reign. If we were talking about functions, then you could, of course, use these other input and output values as well. So when we talk through graphs, that's also handy. What's also nice is, say, for example, we want to know what the value of the 10th term is. All we have to do is scroll until we get to position 10, which is our x, and we can see that it's now 38. If we want to know what our 25th term is, then we could just scroll through and we would see that we have 83. And because your table is unlimited, it really does help to quickly check for those sort of solutions. Of course, we do want them to do the substitution and all of the steps, but this is a good way to check that the answers are actually correct as well. Then, of course, we can work through geometric patterns. So here we are multiplying by a common ratio. So you can see we're not adding, because here we added 9, but here we added 36. So our common ratio is actually multiplying by 4. Oh, sorry. So I'm just going to write 4 here. And then our A would be our first term, which is 3. So our formula would be 3 times 4 to the power of n minus 1, or position minus 1. Again, we can, of course, check this formula and make sure that we've got the right formula using our table mode. So I'll just go back here. Just press on twice to get back to a clear screen for function 1. We can type in our formula, so 3 times 4 to the power of, and again, we don't have an n, we'll use an x minus 1. Okay, I'm moving that just so that you can see it nice and clearly. You don't have to press equals from here. And then function 2, obviously, we're going to ignore for now. Again, leave start and step as 1 and 1. And here we can see that our pattern is in fact correct. So we know that we've got the right formula for our pattern. And again, you can predict any value based on the position. So here you can see now we're getting very large, 805 million, and so on and so forth. So cool. Then we also have to deal with the quadratic or second common difference pattern. Okay, so we should be thinking about it as half a parabola, where the parabola actually cuts at the axis. So there's 2 possible methods, and I'll work through both of them with you here. So the first method is obviously where we have that formula that we memorized. We have a plus b plus c is the first term, 3a plus b is the second term, and 2a is equal to your second difference, which is your number 3 here. So this is we just follow these and they fit into these formulas here. Then, of course, we solve from the bottom to the top. So we find that a is 3/2. Then we substitute a into this one here, and we get b is equal to -2.5. And then we substitute both a and b into our first one, and we find that c is equal to 2. So here's our formula. All right, now we can also work out our c value by first extending the pattern backwards. So here, it's going to be 3 plus 2, so this will be -1. Then here, what -1 would give me 1? Well, that would be 2. So this pattern here is going to be 2 and -1. Now we can see that our c value is 2, which we found previously in the other equation as well. So we know that we are right. But I'll show you a nice checking mechanism. And then, of course, we can now substitute for the first and second terms. So position 1 and position 2, and solve for our a and our b values. So simultaneous equations. So this is, yeah, more towards the end of grades. Well, I mean, we're doing this in grade 11 anyway, so they should be sufficiently able to solve simultaneously. So here's all the steps here. So this method is nice for students who struggle to remember this formula or this patterns formula. It's definitely much more intuitive and straightforward. So I must be honest, I used this in high school, but the more I teach this, the nicer I realize it is. So it's just a nice way to do things as well. We can also do our pattern on our calculator. So what I'm going to do, I just want to oh, there's the pattern. Okay. There we go. Okay, so you can see both the pattern, which is 1, 3, 8, and 16. And so what we're going to do is we're actually going to use our statistics mode. And we're going to use the a plus bx plus cx squared because that's a parabola formula, right? It's just the a and c have switched. So we'll say 2. And in your x, you're going to fill in the position of your pattern. So 1, 2, 3, 4. So we'll just do that quickly. 1, 2, 3, and 4. And then we'll come back up and we'll fill in the pattern value. So it'll be 1 and 3 and 8 and 16. Okay. Now you can also fill in values. So let me just delete that one. So another way to fill in a value is to say 4 and then to press your x comma y in brackets button and then press 16. Okay, and you'll see that it will automatically fill in the table for you. So both ways are useful. This one is particularly nice for when we talk about doing linear regression. Thanks, Numpulino. Okay, so once we've got that, what we do is we then press our change button, and that will just change our calculations or change to our calculation screen. You can see you can easily go back to your dots by just pressing change again, so you can check that you are correct. Now to find the equation of this pattern, we would say alpha and we press 8 and we choose 1 for regression values. And you can see A is 2, B is -2.5, and C is 1.5 or 3 over 2. So when we write it, it's 3 over 2x squared minus 2.5 plus 2, which is exactly the same formula as we had with our previous calculation. Yeah. So it's just good to know that you can check your calculation or check that you have the right formula using your calculator. What's also really nice is if you want to predict a value. So if, for example, we have position 7 and we want to know what the x value is, so we would say second function and y, and it will then tell us that the term value is 58 at position 7. If I have the value is 58 and I want to know what term position I have, I'm looking for my x. So I say second function and my open bracket, which is the x comma y, my x prime there. And you'll see it first gives you 7 and then it gives you -5.3, which we know we ignore because it's not a positive value and patterns only use positive values. So you'd only have 7 as your final solution. Again, it's just nice to be able to check that you've got the right thing on your calculator. Any questions? Are we all good so far? All right, great. Equations. So let me show you the highest common factor and lowest common multiple function. Here we go. So we're going to press home, and home will just take us back to normal mode from whatever other mode we are currently in. So if I wanted to say, for example, the highest common factor of 12 and 18, we would say 12 and then second function and 2 for GCD. GCD is just greatest common divisor, which is exactly the same thing as highest common factor, and 18, and we'd say equals, and it gives us 6. Then if we repeat, we can add as many numbers as we like to this list. Obviously, most of the time, we won't hit more than say 4 or 5, but it's good to know that you can add as many as you want to your list of numbers you're looking for factor pairs of. You can also do the lowest common multiple by saying second function 3 and then typing in your second value. So that's 36. And again, you can add as many numbers as you like to this calculation. It's not going to penalize you. And you'll see that your LCM is 72. So here, this is really nice for working with algebraic fractions and talking through how we find the LCD. So LCD is the same basically as lowest common multiple. It's just a different application as well. Now, for finding factorizing or factorizing, what's really nice is you can actually find factor pairs on the calculator. So here we'll go to table mode. And let's say we want the factor pairs of 98, right? That's not a good example, but anyway. 98, so we press our fraction button. Again, we're going to make an X by pressing RCL twice. Okay, so basically what we're saying is 98 divided by X every time. Then we'll just scroll through the table and we'll see anything divided by 0 is undefined, which is where your asymptote comes from. So you can see the asymptote actually looks like an asymptote on the calculator, which is really nice. And here's all your factor pairs for you. 1 and 98, 2 and 49, 3 and 32.6. So we can see that 3 is not a factor because it has a decimal answer. It has a remainder, so we ignore that one. 4 is also not a factor. 5 is not a factor. 6 is not a factor. 7 is a factor. And then we can just continue scrolling and looking at the rest of our factors. Yeah, so we can see that actually we've run out of factors and we are actually all done now. You see it back again, 14 and 7. So there was the last one there. So we're all done and we know that we've got all of our factors and we can then move on to the next step in our question. So when we talk about factorizing trinomials, we talk about looking at the C value. So the thing without an X or your constant value. So if the C value is a plus, we know the signs in the brackets are the same. And if the signs in the brackets, and then we look at the B value to decide what that sign is. So here's a plus. So my signs must both be a plus here. So we'll just have X plus and X plus. Here, my sign at the back is a plus, but this one is a minus. So in both my brackets, I'm going to have X minus and X minus, like so. Okay. Now, I'm not going to redo the table because the factors of 6 is quite basic. So what you would do is you'd have your table, you'd have 1 and 6, 2 and 3, 3 and 2, and 6 and 1. Now, when your signs are the same, you add your two factors together to get your middle term. So 1 and 6 is 7, not what we're looking for, so that's not right. 2 plus 3 is 5. Yes, that is what I'm looking for, so I can just add the two together. Okay, here again, we've got minus 5, so we'll have minus 1 minus 6 is minus 7, not what we're looking for. Minus 2 minus 3 is minus 5, so I have minus 2 and minus 3, done. Now, when we have where the sign at the back is a negative, right? So we won't fill in the signs. We know that then the signs are different. So what we say is we make one column plus and one column minus. So we're looking for the answer of minus 1. So plus 1 minus 6 gives us minus 5, which is not what we're looking for. Plus 2 minus 3 gives us minus 1. Yes, that is what I'm looking for. So I would have plus 2. Oh, sorry. Mouse is behaving like it does. I'm just going to put it on a piece of paper and hope it works better. So we'll have, so what we'll have is X minus 2 and X plus 3. And then we are, so we've now factorized our bracket. So that's just the way to use the signs and the table to help you find your factor pairs as well. We do have a webinar, which is just purely on factorizing, where I go through all of the steps. So we talk about the box method, the Khan Academy method, the airplane method. So there's a whole bunch of different methods, particularly for when we have values where our A is not 1. And then it makes factorizing that much more complicated. So that is quite a nice webinar to go through if you're looking for new methods for teaching factorizing. So let's move then on to the quadratic formula, which we do in grade 11. So I just want to move this across so you can see my formula. And there we go. Okay, so again, this is something that we're going to do in normal mode. And what we're going to do is we're actually going to store our A, B, and C values into our memory keys. So our A value is 3. So we would say 3 and store it into A. Then we've got B is negative 51. So we would use our negative button first and type in 51 and store it into B. And then C, we would say 17 and store it into C. Now what we do is we type in the formula using our alpha button. So we'll have negative alpha B plus or minus. So I'm just going to use plus here. And then we have square root and then alpha B squared minus 4 alpha A alpha C over 2 alpha A. Like so. Okay. So once we've done typed in the formula, we can then press equals and that will give us our first solution. Now, if we want to add the minus, you can just press your left arrow key once to go back to that same formula or expression. Press second function on your left arrow key to go to the front of the thing, just because we're editing right in the front, so it just will save us button presses. Press your backspace button, add a minus, and say equals, and there's our second solution. So we've got both solutions for this equation. Now, what's really great is if, for example, we have another equation where we have different values. So we've got 2 and we can store that into A, and we've got 6 and we store that into B, and then we've got negative 12 and we store that into C. If we then go back up to our previous formula and we press equals, it will then give us a new solution. And again, we can just edit, change our sign and equals, and we'll get the same solution again, or a different, well, a new solution as well. So it's a really nice way to use your calculator to do the quadratic formula. What's also really nice, and which I should mention, is when you are not sure what's saved into your memory keys, you can say alpha 9, and it will actually show you what you've got saved so far in your calculator, which does make things easier to check as well. Okay, let's talk trigonometry. So let me give you, I'm going to just give you 2 shortcuts first. So the first shortcut is your D1 and D2, D3 keys. So if, for example, you, and this is particularly handy for grade 10, when they're still learning which one gives them the angle and which one gives them the ratio. So what you would do is say, store into D1, and then you would say second function and sine. And what happens then is when I press D1, I've now got second function sine or arc sine in my calculator. So I don't have to press 2 buttons now. I can just press 1. And then I can put in my ratio and I can get my angle. If I put in my sine of my angle, I should get my ratio as well. So what's nice here is that it just is a bit of a time saver, and then you can remind them that D stands for degrees. So then you would have, this one is to find your ratio, and this one is to find your angles or degrees. The other nice shortcut is, for example, when we have a Cartesian plane and we have that point P, and let's say my P value is 11 and 15. Okay, so I'm just using a random one because I'm very bored of Pythagorean triples. So what we do is we type in our x first, which is 11, press our x, comma, y in brackets button, type in 15, and then we would say second function and number 8. You'll see above 8, it says arrow r theta. So you'll see your hypotenuse is 18.6, and the angle that the hypotenuse makes is 53.7. 4. So here we're talking about the length of this line as well as the angle that it makes with your x-axis. So those are the two values that you get there. What's also really nice is that these values are now stored into your memory key. So you'll see when I press alpha in memory, it's now in your x and y values. So if you wanted to use them in a calculation, so for example, if we said cos and we used L for y for the angle value, it should then give us the ratio. So if we're doing calculations, you know, we find the side of the triangle and all of that sort of stuff, then you've got it saved and you don't have to retype in that entire angle every time. So it does make it a bit quicker and saves you some time. Now, I'm not going to use the sine function for this because I've actually filled in the values on the table. What I want to do is the cos version, just to show you. And I want to show you how to teach the cos diagram or explain it just using a basic calculator thing. Okay, so we're going to go to table mode. And we're just going to draw a basic cos graph. So we're going to say cos and RCL to make an X. In our start, I'm going to start at negative 180. So I'm going to use my negative sign. And my step, I could do steps of 1, but it would take me a long time to get through the whole table. So I'm going to just rather make it steps of 15. Then we would press equals. And here we can see that between negative 180 and negative 90, all of our answers are negative. So I'll put a negative sign here. Between negative 90 and 0, our answers are positive. So I'll put a plus here. Between 0 and 90, our answers are all positive. So I'll add a plus, there. Then between 90 and 180, our answers are negative. So that's already filled in. Then between 180 and 270, our answers are negative. And between 270 and 360, our answers are positive again. So once we've completed this table, what we'll do is draw a Cartesian plane like so, well, except that we're using now degrees. So what we can see is sine is only positive between 0 and 90. Sine is positive there, and sine is positive between 90 and 180. So positive there. Cos is positive between 0 and 90. So it's positive there. And it's also positive between 0 and negative 90. So here. Or between 270 and 360, which is the same quadrant. Now, if we went through tan, we would see that tan is positive here, and it's positive in this quadrant here between 180 and 270. Now, we can see that all of our trig equations are positive in the first quadrant, and that is where the cost diagram comes from. And this is a really nice way to walk through why your cost diagram works the way it does. It's because your pattern on your table keeps repeating over and over, because your trig graph is basically a repetitive graph. It does the same thing over and over and over again within a certain space. So I'm not going to do through the basics of solving this trig equation with you. What I do want to show you is the solutions for general solution, to go from a general solution to a specific solution. So what we'll do is on our calculator in table mode, in my function 1, I'm going to type in my first general solution, which is this negative 10.53 plus, and then instead of a k, I'm going to use an x instead, times 360. And then in function 2, I'll put my second general solution, which is 130.53 plus, and then k is an x, because we don't obviously have a k to do this with, and then we would say equals. Now here we'll make our start at negative 1, and our step will make 1, because now we're substituting integers, so we're substituting for k as negative 1, 0, 1, 2. So that's why we changed those there. And here we can see we're looking for specific solutions between 30 and 200 degrees. So if I look at my table, I can see the first answer is negative 370. So that doesn't fall within our required space. Then you've got negative 229. Then you've got negative 10, which is also not a solution. Then you've got 130.53, which is a solution. And then if we go down one more, you can see that it's 349, which is greater than 200. So that's not a solution. So we can see that the only specific solution for this question is 130.53 degrees. So it's a really nice way to do the trigonometry solutions. So we can also do functions. Is everybody happy? Any questions? We still good? Okay, great, fantastic. So if we wanted to talk through working through a parabola, so what you can do is in your table, you can add an x squared. So again, you're using table mode. And what you would do in your second function is to multiply your x squared by 2. And then, of course, to see the solutions here. Now, if you graph them, what would happen is your original graph would be this blue one here. Okay, and your red graph is the 2x squared. And we can see that it's thinner than the original graph because your a value is greater. Now, what happens if we made our a value smaller than 1? So we'll go through those steps. And here you can see, again, this is the original blue graph. And then your red graph is wider because your a value is smaller than 1. So you can see that the closer the a value gets to 0, the wider the graph will be, whereas the closer it gets, or the higher the value of a is, the closer it will get to your your y-axis. Then we can also look at shifting your graph up and down and doing all of that experiments. And we can see once we draw those graphs from our data points on the table, that it doesn't change the shape of the graph, it only moves the graph up or down. If we talk about shifting to the left and the right, then we can see here that the shape of the graph is still the same. It's just shifted over to the left. So that's the different ways that you can explore this. We have a very nice grade 10 study guide, which I've just redone, which has all of these exercises where students can go and draw the graphs and look at what happens to the shape of the graph, etc. Because they do actually have to understand what the A and P and Q values do to your graph. Okay, still no questions? We all good? All right, I think finance, growth, and decay is the last section here. So I just want to do simple interest with you quickly. And again, we're going to use our table mode. So what I'm going to do is I'm just going to type in a basic formula. So we'll have 1,000 Rand, and we invested at 8% per, 8% per year. And it's simple interest, so we're going to say times and then RCL to give us an X and close our brackets and equals. I'm going to just delete that function by pressing on, and then we'll say equals. I'll make my start at 0, obviously, and step is the 1. And here we can see that after 1 year, we earned 80 Rand. And after 2 years, we've earned 160 Rand or 80 Rand added to the previous year. And after 3 years, we've added another 80 Rand. And after 4 years, we've added another 80 Rand. So you can see the increase is the original 8% of my initial value. Now, if we talk through compound interest, so again, I can use compound interest. I'll use the same values just so that it's nice to compare. And here we'll have to the power of X. We'll say equals. Now we can see after year 1, they both earned 80 Rand. But after year 2, the compound interest has earned an extra 6.40 Rand compared to the simple interest because it's taking 8% of the previous year and not 8% of the initial value like our simple interest. And here you can see how much faster your compound interest grows compared to your simple interest. So some nice questions are, when does your simple interest double? When does your compound interest double? So we can see here, our compound interest account has basically doubled after 9 years, whereas our simple interest account is going to take in 13 years to reach double its value. And then we can also look for when our compound interest doubles the value of our simple interest. So we can just scroll through that. Looks there, it's probably about there. So between 22 and 23 years, then our compound interest has double the value or double the amount of money in it than the simple interest account. So you can see really how effective the compounding value of compound interest actually is. So I've just used different values just to mix it up and stuff and to give you an idea. So the other nice thing to do is also to do your present or future value annuities. And we were discussing this last night with the IB group. So I just put this here. Cool. So this is our formula here. So what we're actually doing is we're saying, okay, I want to look at what I can borrow versus what I'm willing to pay back on a monthly basis. If my interest rate is 10% per annum and I'm paying it back over 5 years. So on the calculator, we would put in an X in place of the monthly repayment value. Type in our formula, oopsie, 1 plus 10%, and then it's compounded monthly, so times 12 to the power of -5, and it is being repaid over monthly as well. So close that. And then at the bottom is our interest rate again, which is compounded monthly. Okay, now I know I've done this very fast for you, but when you've got the instructions in front of you, you can follow along and do those this with you as well. It does take a little bit of practice just to get used to the calculator as well. Okay, delete function 2 because we don't want to create confusion. Let's leave our starting step at 0, 1, just to make a point. So what's actually happening here is what we're saying is if I can afford to pay back R1 a month for 5 years, I can borrow 47 Rand right now. If I can pay back 10 Rand a month, I can borrow 470 Rand over 5 years. If I can pay back 20 Rand a month, I can borrow 941 Rand for 5 years. Now, this is very small values. It's not really realistic. So what we could then do is change our steps to say something like 100 and go through the table. So now we can see, okay, if I can afford to pay back 200 Rand a month, I can now borrow 9,400 Rand over 5 years at 10% per annum. Or if I can afford to pay back 1,000 Rand a month, I can borrow 47,000 Rand. Or let's say I want to purchase a car which is 150,000. So now I can go through my table and go look and see where's 150,000. It's here at 3,200. So if I want a car that's worth 150,000 Rand, I would need to be able to pay back 3,200 Rand per month over 5 years at a 10% per annum simple interest rate. What's cool here is you can now go back and edit. So for example, let's say that our interest rate is actually 9.5%. And instead of borrowing it over 5 years, we borrow it over 6 years. So I'm doing a double here, double change. Okay, so we've changed the interest rates, we've changed the number of years. And if we go back through and now we want to borrow 150,000 Rand, we can see, sorry, I'm scrolling through the table, here we go. So our repayments now would be between 2,700 and 2,800 Rand a month. Okay, and that's over 6 years instead of over 5 years and a lower interest rate. So it makes a difference of about 500 Rand here. But if you think about it, you're borrowing, the difference is 500 Rand. So your interest rate over 6 years is going to be, sorry, hang on. So 500 Rand over a year is 6,000 Rand, right? But you're paying an additional 2,800 Rand a month for the next year as well. So then it mitigates that savings. You're actually paying more in interest when you take out a longer loan period as well. So just some thoughts around that. All right, great. Any questions, any thoughts? Thank you so much for joining us today with this video. And for those of you who have watched this on YouTube, you can find all of our worksheets and the simulator that we use on this video for free to download with Maths at Sharp. Otherwise, please like and subscribe and share with your maths teacher friends or your other maths friends for that matter.